Friends, welcome to the class. Today we'll discuss about trigonometry. Trigonometry is a branch of mathematics that deals with the relationship between the sides and angles of a triangle. The word trigonometry is derived from three Greek words, tri, gon and metron. Tri means three, gon means sides, and metron means measurement. So trigonometry basically deals with the relationship between the sides and angles of a triangle. What are trigonometric ratios? The ratio of the sides of a right-angled triangle with respect to its acute angles are called trigonometric ratios. The trigonometric ratios are also known as T ratios. In any right-angled triangle for any acute angle, the side opposite to the angle is called perpendicular, denoted by P. The side adjacent to the acute angle is called base and denoted by B. And the side opposite to the right angle is called hypotenuse, denoted by capital H. That particular angle, that particular acute angle is called the angle of reference. Let's discuss in detail that there are three triangles. Example 1, example 2, example 3. In the first diagram, in triangle ABC, angle B is, in triangle ABC, angle B is 90 degree, angle C is the angle of reference. So the side opposite to angle C is AB. So AB is perpendicular. The side adjacent to angle C is BC. So base is BC. And the side opposite to the right angle, that means opposite to angle B, is AC. So AC is hypotenuse. Similarly, in diagram 2, in triangle PQR, angle Q is 90 degree, angle P is the angle of reference. So if we take P as the angle of reference, the side opposite to angle P is QR. So in this case, perpendicular is QR. The base is the side adjacent to the angle P, that means PQ is the base, and as usual hypotenuse is the side opposite to right angle, that means opposite to angle Q, which is PR. So hypotenuse is PR. So in example 3 or diagram 3, we can find, if we take Z as the angle of reference, XY is perpendicular, YZ is base, and ZX is the hypotenuse. Now there are 6 trigonometric ratios. They are sine, cosine, tangent, cosine, secant, cotangent. Sine is the ratio of the perpendicular to that angle to hypotenuse. That means sine of any given angle is P by H. Cosine of an angle is the ratio of the base to that angle to hypotenuse. That means cosine of that angle is B by H. Tangent of an angle is the ratio of the perpendicular to that angle to base. That means tangent of that angle is P by B. Cosine of an angle is the ratio of hypotenuse to perpendicular. That means it is H by P. Secant of an angle is the ratio of hypotenuse to base. That means it is H by B. Cotangent of an angle is the ratio of the base to perpendicular. That means cotangent of that angle is B by P. So here take the same diagram into account. So in diagram 1, angle B is right angle C is the angle of reference. So here perpendicular is AB, base is BC, and AC is hypotenuse. So if we take C as the angle of reference, sine of angle C or sine C is perpendicular by hypotenuse, that means AB by AC. Cosine of angle C or cos C is base by hypotenuse, that is BC by AC. Tangent of angle C is perpendicular by base, that is AB by BC. Cosine of angle C is hypotenuse by perpendicular, that is AC by AB. Secant of angle C is hypotenuse by base, that is AC by BC, and cotangent of angle C or cot C is base by perpendicular, that is BC by AB. Now let's come to diagram 2. In diagram 2, angle P is taken as the angle of reference. So it is quite clear QR is perpendicular, PQ is the base, and PR is the hypotenuse. So sine P or sine of angle P is perpendicular by hypotenuse, that means QR by PR. Cosine of angle P or cos P is base by hypotenuse, that is QP by PR. Tangent of angle P is perpendicular by base, that means QR by PQ. Cosine of angle P is hypotenuse by perpendicular, that is PR by QR. Secant of angle P or sec P is hypotenuse by base, that is PR by PQ, and cotangent of angle P or cot P is base by perpendicular, that is PQ by QR. Likewise, in diagram 3, if we take Z as the angle of reference, then sin Z is xy by xz, cos Z equals to yz by xz, tan Z is xy by yz, cosec Z is xz by xy, sec Z is xz by yz, and cot Z is xz by xy. Now, some important points to be remember. The symbol sin C is used as the abbreviation for sine of angle C. It is not the product of the word sine and angle C. And if they are separated, it has no meaning. Each trigonometric ratio is a real number and has no unit. The value of each trigonometric ratio of an angle does not depend upon the size of the triangle or length of the sides of the triangle. It depends only on the angle, the value of the angle. It doesn't matter what is the length or breadth of the sides. And if one trigonometric ratio is known, the remaining 5 trigonometric ratios can be derived from that particular value. Let's see an example. If sine A equals to 3 by 5, find other trigonometric ratios. Given sine A equals to 3 by 5, we know sine A equals to P by H for some acute angle A. So on equating P by H equals to 3 by 5, we get P equals to 3, H equals to 5. Now we can find out what is B, means base. So using hypotenuse theorem, base equals to square root of h square minus p square. Putting the values, we get b equals to square root of 5 square minus 3 square, or which is equals to 4. So we got b, p and h. So using these three, base, perpendicular and hypotenuse, we can find out the other trigonometric ratios. So let's see that. Cos A equals to b by h equals to 4 by 5. Tan A equals to p by b equals to 3 by 4. Cosec A equals to h by p equals to 5 by 3. Sec A is equal to h by p equals to 5 by 4. And cot A equals to b by p equals to 4 by 3. Let's see another example. In the following figure, find tan p minus cot r. The question itself says that here we have to take two angle of reference. One is angle p and the other one is angle r. Let's see the diagram. Let's go for solving it. Given that PQ equals to 8 centimeter, PR equals to 10 centimeter. In triangle PQR, PR is hypotenuse. So by applying Pythagoras theorem, we get QR equals to square root of PR square minus PQ square, or it is square root of 10 square minus 8 square, which is equal to 6 centimeter. We know tan P equals to P by B, or in this triangle it is QR by QP. So tan P equals to 6 by 8. Cot R equals to B by P, or base by hypotenuse, base by perpendicular. And in this triangle it is also QR by QP, that is 6 by 8. So tan P minus cot R is 6 by 8 minus 6 by 8, which is equals to 0. So thus the answer is 0. Let's see another example. In triangle PQR, right angle at Q, QR equals to 3 centimeter, PR minus PQ equals to 1 centimeter. Find the value of sin R, cos R, and tan R. Let's draw the picture. Now the given is in triangle PQR, QR equals to 90 degree, QR equals to 3 centimeter, and PR minus PQ equals to 1. So applying Pythagoras theorem, in triangle PQR we get PR square equal to PQ square plus QR square, or you can write PR square minus PQ square equal to QR square, or using that identity we get PR square minus PQ square is PR plus PQ whole into PR minus PQ equals to 9, or it is PR plus PQ equals to 9, because already it is given PR minus PQ equals to 1. So we got two equations, PR plus PQ equals to 9, let this is first equation, and PR minus PQ equals to 1, let this is second equation. On solving we get PR equals to 5 centimeter and PQ equals to 4 centimeter. Now QR is square root of PR square minus PQ square, or it is square root of 5 square minus 4 square, or QR equals to 3 centimeter. So in this triangle we got all the three sides, PR, PQ and QR. So you can find the trigonometric ratios. Now sin R is PQ by PR, because when you take the angle of reference to be R, PQ is perpendicular and PR is the hypotenuse. So sin R is PQ by PR, which is equal to 4 by 5. Cos R is base by hypotenuse, that means QR by PR, which is equal to 3 by 5. And tan R is perpendicular by base, which is PR by QR, which is equal to 3 by 4. Friends, here is so few examples, few questions. The more and more such questions you do, the easier it becomes, the more you like it. So friends, practice more and more such questions, and in case of any difficulty, any doubt, do share your question with me. It will be a pleasure for me if I can help you out in solving your questions, your doubts. So this much for today's class. Thank you.